Welcome back to For the Mariners by the Mariners channel. In the wake of increasingly stringent international maritime regulations aimed at reducing air pollution, the Selective Catalytic Reduction system has emerged as the premier technology for neutralizing harmful nitrogen oxide emissions from ship exhaust. The core working principle of an SCR system involves the injection of a liquid reducing agent, typically a 32.5% urea solution known as aqueous urea, into the hot exhaust gas stream before it passes through a catalytic converter. Inside the reactor, the urea undergoes a thermal decomposition and hydrolysis process to form ammonia, which then reacts with the nitrogen oxides over a catalyst bed to transform the pollutants into harmless nitrogen gas and water vapor. The effectiveness of this chemical reaction depends entirely on the precision of the dosing control system, which must dynamically adjust the amount of urea injected based on the real-time engine load and exhaust gas conditions. At the heart of the dosing unit is a sophisticated controller that receives input data from nitrogen oxide sensors located both upstream and downstream of the catalyst, along with data on exhaust gas temperature, flow rate, and engine speed. The control logic utilizes a feed-forward mechanism to estimate the required urea flow based on the engine's current fuel consumption and combustion characteristics, while simultaneously using a feedback loop from the downstream sensor to fine-tune the injection rate. This dual approach is critical because injecting too little urea will result in a failure to meet emission standards, while injecting too much leads to a phenomenon known as ammonia slip, where unreacted ammonia is exhausted into the atmosphere, causing environmental damage and wasting expensive chemical resources. Temperature management is another vital aspect of dosing control, as the exhaust must be within a specific window, typically between 300 and 400 degrees Celsius, to ensure the catalyst remains active and to prevent the formation of ammonium bisulfate, which can foul the catalytic surfaces. The dosing system also manages the compressed air used for atomization, ensuring the urea is sprayed as a fine mist to maximize the surface area for the reaction and to prevent the buildup of solid urea deposits inside the exhaust ducting. During low-load operations, or when the ship is outside of emission control areas, the dosing controller can automatically bypass or throttle the system to optimize operational costs while maintaining compliance. Regular maintenance of the dosing pumps, filters, and injection nozzles is essential to prevent blockages and ensure the volumetric accuracy of the system over thousands of operating hours. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.